Okay, so this is kind of a challenging problem here. Radioactive substance decays exponentially. Scientist begins with 170 milligrams of the radioactive substance. After 27 hours, 85 milligrams remains. How many milligrams remain after 31 hours? Okay, go to the notes. So here's the exam 4 notes. Continuous or exponential? That's the keyword. Do you see how it's said right there? Decays exponentially. So when you see that, you go, oh, exponential growth or decay. So continuous or exponential growth or decay. Want to use PERT. Plug in the starting information. Find e to the r. Okay, I'll guide you through all this. So step number 1 is plug in the and is write the formula. And step 2 is plug into it. Okay. Step number 1. So write. Or what am I doing? A equals PERT. This is the same formula we used when we had money being compounded continuously. Exponential or continuous money or biological or radioactive chemical substances, it's all the same thing. So step 2, plug in, begins with 170. So that's the P. You good so far? P, it's like the principal in money, principal, it's the starting amount. So for money, it's the principal. For, a chemistry problem, it's the starting amount. Okay. And then after 27 hours, so when T is 27, the amount has become 85, right? It goes down. It started at 170, but it's decaying. It's going down and down. It's going away into the atmosphere. So this radioactive substance is kind of dissipating into the atmosphere, which is perhaps a little scary. But and after 27 hours, it's down to 85 milligrams left. It started at 170. So that means if we plug in an amount, the amount has become 85 when the time is 27 hours. Does that make sense? So now, so I plugged in, this is what they're saying on step 2. Plug in the starting information, like there. Now, plug in later information to find e to the r. Oh, yeah, they did it in 2 steps. Yeah, just the starting information, just got that, and now find e to the r. So I'm gonna solve. See how down here I found e to the r in these steps? It's all about solving for e to the r. So now this is like step 3. Solve for e to the r, meaning this piece right there I want to get. So it's a little weird. I want to show you about this. It's a little weird to actually get like e to the r alone, but that's what we want to do. So let me go over here and show you that. So 85 is 170 e to the r times 27. So the first step is going to be to divide by 170 on both sides like that. And do they want me to go to decimals, or I think I'm just going to leave it. I'm just going to leave it for now. I think it might be a little easier that way, actually. So what do we get? So this is just 85 over 170 is e to the r times 27. Are we good so far? Now, how do I get rid of that 27 that's in the power? Well, look at what they did in the notes. What I did, I wrote the notes. To get rid of that 34, raise both sides to the 1 over 34 power, and then it cancels, and you get e to the r alone. See that? See how that worked? So let's do that. So I'm going to take that 85 over 170 equals e to the r times 27. Then I'm going to raise both sides to the 1 over 27 power, and it'll cancel that out. It's kind of weird, huh? So we get, what do we get? 85 over 170 to the 1 over 27 power is e to the r, because the 27 has canceled out. It's just e to the r. So we solved for e to the r. No, why did we do that? Well, let's go down here. And then rewrite a equals putting that in the place of e to the r. So now I'm going to rewrite the formula here. It's A equals P e to the RT. But now I have a lot of information. Know the P, what was that, 170 or something? Yeah, the P is the principal starting amount, 170. 170 e to the R, well, that's this. That's 85 over 170 to the 1 over 27, all to the T. Well, the T ends up going on the top of here. Because the T is in the power. Does that make sense? That's what I showed right here. See that? So there, we're not done yet, but there's our rewrite. That making sense? How I put that T in the top? A lot of people get confused by that T. Let me slow down and go over that again. There's the T, right? See how the e to the R is all of this. So all of this, 1 over 27. You might go, well, where's the 1? Well, the 1's here if you want. 1 times T, that's just T, right? Right? 85 over 170 to the 127 to the T. So the T times 1 is just T on the top. Is that good? So there's the rewrite. There's our formula. Now step 4, plug in your final time. So step 4, we're ready to wrap it. Plug in final time. What is the final? What did they ask us? How much after 31 hours? How much will remain after 31 hours? So T equals 31. So we'll take this formula. A is 170. 85 over 170 to the T. Let me make that a little bit better. T over 21. Take that 31, plug it in right there for T, right? And so we get 170 times 85 over 170 to the 37, no, 31. I just can't read my writing here. 31 over 27, like that. So hit the buttons on your calculator. You're going to need to put parentheses around that stuff, right? You need to go 170 parenthesis 85 divided by 170 to the power, up arrow or whatever your power button is, 31 divided by 27, close parenthesis, equal sign or enter or whatever is on your calculator. Like that. That's basically what you're going to have to do. So times parentheses, you got to put 85 divided by 170 in parentheses to the power, parenthesis, 31 divided by 27. So I'm getting, I'm getting A equals 76.7047. So again, one more time, let me make sure we're clear on this. Parenthesis here, parenthesis there, right? Why? Because remember, we always have to parenthesize anything that we're saying is a group. So the 85 over 170 is a whole fraction group raised to the over 27 power. You got to put parentheses, whenever you have more than one item in a zone. So we have, you know, a power zone here. You got to put parentheses around that. You get 76.7047. That's the amount. And it makes sense it goes down, right? It was 170 milligrams at first. After 27 hours, it was down to 85. So after 31 hours, it'll be even lower. And this is a little bit lower than 85. It makes sense. It's going down over time. So there we go.